Alright, so this video we're going to look at finding the equation of a parabola. But before we do, let's take a look at the equations. So the equation of a parabola, we have x squared equals 4py. Well, that's a parabola that's going to either open up or down because the x is squared. And, whether it opens up or down, that's going to be based on what value p is. And then we have one that's going to open either left or right. Y squared equals 4px. See, the y is squared. And whether it opens left or right, that's going to depend on p. Remember, one that opens to the right, p will be positive. One that opens to the left, p will be negative. And same thing up here. If p is positive, it'll open up. If p is negative, it will open down. And then we also have the focus and the directrix. So on one that opens upward, so let's say we have a parabola here. Okay, this would be your focus. Here's your vertex. So your focus, this distance from here to here is p. That's that distance, p. And then p units down would be your directrix. Okay, so that's what we're looking for. See, once we find p, we can get the coordinates of the uh, focus and we can get the directrix. And then same thing over here, except, it's either going to open right or left. So if we look at this, if the focus is here, of course, this distance to here would be p, and then the directrix would be back here, p units. Okay. Now, you know, don't try to memorize, okay, well, I got to add p to this to get the directrix, or got to add p to this, or subtract p to get the focus. The best thing to do is you're gonna just sketch out the information you're given, and it makes it a lot easier to work. And plus, not all the parabolas are going to be at the vertex is going to be at 0, 0. Sometimes it may not. And so another way to write these, when they're, see here, the vertex is at 0, 0. But if we look at it, x minus h squared equals 4p times y minus k. And then here we would have y minus k squared equals 4p times x minus h. And the vertex would be hk. All right, so let's go ahead and take a look at an example. All right, so let's take a look at some examples we have here. We want to find the vertex, the focus, and the directrix for each of these. There's two problems. They're each a little bit different, so watch them both. All right, so let's go ahead and get started on A. All right, so the first thing I like to do is see what I have here and which form we're going to use. So if you remember from the formulas we had earlier, we can see this is what x minus k squared equals 4p times x minus h. Okay, so that's the form we have because we have the y term is squared, and we know it's either going to open left or right. So let's go ahead and write our problem down. Okay. Now I want to get a positive in front of the squared part, so we'll multiply by -1. So that's going to give me y squared equals -2x. And notice I wrote the y squared on the left. You don't have to do that. I just like to put it on the left and make everything look like the formula here. All right. So now let's go ahead and get the vertex. So as far as the vertex goes, let's see what we've got. Well, we've got just y squared. There's no k term, so k is 0. And then here we just have an x term, so
h is 0 also, so our vertex is 0, 0. Okay. Now let's just make a rough sketch of the graph to see what we have. Okay. So I'm gonna draw it closer over here. Okay. So our vertex is at 0, 0, which is right here. And which way is it going to open? Well, it's going to open to the left because we've got a negative here. Okay, if this were positive, it would open up to the right. But we know this is going to open up to the left. And so it's not a very good graph, but that's all we need. All right, so this is the best thing to do when you go to find the focus in the directrix. Go ahead and just make a rough sketch. And then all we have to do is just sketch in the focus and just sketch in the directrix, which is maybe about right in there somewhere. Okay. So we know that the distance from the vertex to the directrix is P, and the distance from the focus to the vertex is also P. So what we need to do is we need to figure out what P is, and then look, the point's moving left and right, so whatever P is, we can just add to our X value, our X coordinate, and that'll give us our focus, and then the equation of the line for our directrix. So let's get P. All right, so P, we've got what? 4P. See, there's 4P in front of X. Well, what do we have in front of X? Negative 2. So 4P is equal to negative 2. And if we solve, we get P equals negative 1/2. So that's P. So we know the distance from here to here is a half, and the distance from here to here is a half. And we know that the coordinates of the vertex, that's 0, 0. And so if we go from here to here, well, the y coordinate of that is 0, right? Because we're not moving up or down. Well, what's the x coordinate? Well, we're going to the left, what, a half a unit. So 0 plus a half would be a half. And then if we go from here to here, well, we're going, I'm sorry, not a half, negative 1/2, okay? Because we're going to the left. So we've got to subtract a half from 0. All right, now if we go to the right, well, we're what? We're adding a half to that x. So this would be what? That x value would be 1/2. So we've got the focus. We've got the focus would be the point what? Negative 1/2, 0. And the directrix, well, it's a vertical line. So the equation of a vertical line is x equal, and that would be going through 1/2. And so there's your solution. All right, so let's take a look at the next problem. All right, so now the second problem. So what we've got here is we've got y squared plus 2y plus 12x plus 25 equals 0. All right, so it looks like in this one we're going to have the y part squared because see, there's a y squared, there's not an x squared. So what we need to do is notice all the the y terms are over here on the left and the x terms are over here on the right. So let's move these terms, and the x term and the constant term. So let's move that and just keep the y terms over here. So that's going to give us what? Y squared plus 2y, and I'm going to leave me a little space here, equals negative 12x minus 25. And you can probably guess what we're fixing to do. So let's look at this. So what we need to do is get it to look like this. So we're going to complete the square. So if you remember how to do that, we take the 2, we half it, that gives us 1, and then we square it, and 1 squared is 1. So we're going to add that to both sides. And so that's going to give us y plus 1 squared equals negative 12x minus 24. All right, now this left-hand side looks like this, but the right-hand side doesn't look like this over here. So, see, I just need an x right here, okay? So I just need an x, so I need to factor out a negative 12. So I've got y plus 1 squared equals negative 12 times x plus 2, okay? And so now we have our parabola in this form, all right? So let's go ahead and get the vertex. So remember, the vertex is HK, okay? So we can see we've got a 1 and a 2 here. So the vertex is going to be negative 2, negative 1. Remember that the H and K is going to have the opposite sign of what you see here because of the minuses in the formula. All right, so we've got the vertex. So now let's just make a little sketch of the of what we've got so far. All right, so let's say we've got negative 1, negative 1, negative 2. Okay, so, and then negative 1. So our vertex is about right in here. And we'll just make a quick sketch. Okay, now let's go ahead and draw our where our focus would be and our directrix. Okay, but I guess before we do that, let's just go ahead and find P. Okay, so what's P? Well, and also I didn't mention, we know the parabola is opening left because this number here, the number in front of the x part, that's negative, so we know it's opening left, and also because the y term is squared, so it's either going to open left or right. All right, so let's go ahead and find P first before we draw in the focus and the directrix. All right, so the 4P is the part in front of the x minus h. Well, what do we have in front? We've got negative 12. So we've got 4P is equal to negative 12. So P is equal to negative 3. Okay. All right, so look what we have here. If we just kind of sketch in our focus and we sketch in the directrix, actually, you know, the directrix and the focus is what? This distance from here to here is what? That's 3 units away, right? And so the distance from here to our directrix is also going to be 3 units. That's actually going to take it to the, see, 1, 2, it's going to take it over here to the other side. And so we can see that our directrix would be right in here. And I know this is not drawn to scale. I mean, I guess if we wanted to, we pull it out more over here, draw it down. But, you know, that's not really important. It's really, now, you know, if you were making this a final graph, yeah, that would be important. But we're just sketching this to get an idea how we need to find our points. Okay, so here we've got our vertex is negative 2, negative 1. There's our vertex. All right, so now let's get the focus and the directrix. Well, I know from this point I'm going 3 units this way to the focus, and I'm going 3 units to the right to get to the directrix. All right, well, let's see. The focus and the directrix. All right, so the focus, well, from here it's 3 units, that's P, okay? So it's 3 units. So we've got, let's see, well, this point is going to stay at negative 1, right? because we're not moving up or down, but we're going 3 units this way. So that would be what? That would be -5. So there's our focus, -5, -1. And then for the equation of the directrix, well, I'm 3 units, so I'm here at -2. So I would go -1, 0, and this right here would be x value of 1. And so the directrix, it's a vertical line, so we know it's in the form x equals, and what is that? X equal 1. And so I know this is my solution. So I hope the video helped. I know it's kind of long, but give me a like, share, and subscribe, and check out my other videos, and thanks for watching.